Welcome to your weekly AI Digest. This is week 33 of 2026. Today we'll cover 3 topics. Let's get started. In the quest for software-defined vehicles, Panasonic Automotive has unveiled its innovative vSkipGen, a next-generation cockpit domain controller (CDC) virtualization platform. The technology is backed by Google Cloud's C4A-metal infrastructure, offering solutions that promise to revolutionize automotive software development. This article explores why this development is pivotal for the automotive industry. Traditionally, developing in-cabin experiences for vehicles has faced substantial challenges. The automotive landscape is rapidly shifting towards software-defined vehicles, necessitating a more agile approach for development teams. Companies have historically relied on outdated physical prototypes, which not only slow down the innovation process, but also restrict capacity in terms of performance and testing methodologies. The emergence of cockpit domain controllers is a response to these limitations, enabling more complex and integrated user experiences within vehicles. These CDCs facilitate the management of multiple subsystems, allowing for greater flexibility and smoother operation. However, developing the software to leverage these systems requires a robust environment devoid of hardware constraints, which is where Panasonic's vSkipGen comes into play. At its core, Panasonic Automotive's vSkipGen addresses the fundamental issues related to developing software-defined vehicles by providing a cloud-native solution through Google Cloud's C4A-metal infrastructure. The platform enables teams to innovate without the constraints of traditional hardware limitations, streamlining the development process significantly. C4A-metal, the backbone of the vSkipGen platform, offers impressive specifications: 96 virtual CPUs, 2 DDR5 memory configurations of 384 GB and 768 GB, and networking bandwidth of up to 100 gigabits per second. These specifications make it ideally suited for demanding tasks such as simulating digital twins of vehicle environments, ensuring performance closely resembles that of actual hardware. One of the most significant advantages of C4A-metal is its ability to bypass the limitations of traditional hardware. With high-performance capabilities and hardware-level access provided within a scalable cloud environment, developers can execute complex virtualization tasks without the overhead of physical systems. This streamlining directly translates to reduced lead times in software development and validation. According to Andrew Poliak, CTO of Panasonic Automotive Systems America, leveraging Axion bare metal has revolutionized the vSkipGen platform. It allows teams to develop and test production-ready software in an environment that closely mirrors target automotive hardware, ensuring that the transition from development to deployment is as smooth as possible. This transition not only improves validation efficiency, but also significantly enhances test coverage. With vSkipGen, the automotive industry can now build, test, and validate complete Android automotive OS stacks in a hardware-independent landscape. This transition signifies a major cultural shift, moving from dependence on physical prototypes to a more flexible, digital-centric approach where virtualization plays a fundamental role. The implications of this technology extend beyond immediate development practices. As automotive manufacturers adopt cloud-native solutions like vSkipGen, innovation cycles are expected to shorten, paving the way for faster rollouts of new features and upgrades. A future driven by software-defined capabilities could redefine user experiences in vehicles across various segments. In conclusion, Panasonic Automotive's vSkipGen and Google Cloud's C4A-metal are reshaping the landscape for automotive software development. As the industry embraces these cloud-based solutions, the transition to software-defined vehicles stands to benefit significantly, promising faster innovations for future in-cabin experiences. In a world where application downtime can jeopardize both reputation and revenue, effective deployment strategies become crucial. An article from Google Cloud explores how enhanced multi-region services on Cloud Run can provide resilience against failures while minimizing complexity. It is essential to understand the implications of these updates as they provide a roadmap for businesses relying on mission-critical services. The backdrop to these enhancements lies in the growing demand for reliability among cloud computing users. As businesses shift operations online, they face increased pressure to ensure that applications remain available across different regions. Downtime not only disrupts user experience, but can also lead to significant financial losses. Traditionally, setting up multi-region deployments required intricate configurations, often leading to manual resolutions during outages. Moreover, the first wave of cloud adoption often resulted in single-region approaches, which proved susceptible to local outages and downtime. This has pushed the industry towards more complex architectures that, while increased in resilience, brought their own challenges. Multi-region deployments typically demanded experienced engineering teams to ensure proper setup and fallback strategies, creating barriers for many organizations looking to improve service uptime. The core thesis of the article is that Cloud Run's multi-region services provide a simplified, one-command method to launch applications across various regions. This new capability aims to significantly reduce the complexity involved in deploying high-availability services, allowing organizations to manage and recover from disruptions more seamlessly. Cloud Run achieves this simplification through several innovative features. Readiness probes are a key component of this enhancement. They provide critical, instance-level health checks that accurately determine when containers are fit to handle traffic. This immediate feedback loop allows organizations to swiftly respond to issues without prolonged downtime, ensuring a more reliable user experience. Beyond initial readiness, Service Health aggregates these health checks to calculate the overall health of applications in each region. This aggregated data feeds into serverless network endpoint groups, enhancing visibility across deployments. Consequently, when an instance becomes unhealthy, the global external application load balancer can redirect traffic away from that region, reducing service disruptions for end users. The article outlines vital design considerations for achieving optimal configurations with Cloud Run's multi-region capabilities. For instance, organizations must avoid single points of failure by ensuring that every layer of their application, including databases, is equipped with regional redundancies. This ensures that operational capacity remains intact, even if one region encounters issues. Additionally, organizations must consider their data replication strategies. For applications that cannot tolerate data loss, effective synchronization of data across regions becomes crucial. This is particularly important for read and write-heavy applications that rely on constant data flow, making the enhancements to Cloud Run even more vital for ensuring continuity. These enhancements in Cloud Run represent a paradigm shift in how organizations can deploy their applications across multiple regions. The shift towards simplified multi-region services can democratize access to high availability, allowing smaller teams with fewer resources to attain the same level of resilience as larger competitors. This may lead to a more competitive landscape, where even startups can maintain robust, resilient applications. In conclusion, Cloud Run's multi-region services provide organizations with essential tools to enhance their application reliability while minimizing configuration complexities. As the demand for high availability continues to rise, these capabilities could shape future cloud strategies and significantly impact how businesses manage their online presence. In the evolving landscape of artificial intelligence, transparency has emerged as a critical concern. The article AI Transparency, Governance, Explainability, and Data Practices delves into the elements that underpin trustworthy AI systems. Understanding these principles is vital, as the implications reach far into business ethics, regulatory compliance, and the trustworthiness of AI systems used in high-stakes decisions. Before discussing transparency, it's important to recognize the broader context of AI development. The AI sector has grown rapidly, with AI systems being deployed across various industries. However, as these systems influence decisions in hiring, healthcare, and finance, the absence of transparency raises critical ethical questions. Prior to the current transparency discussions, many AI systems operated like black boxes. Stakeholders, including developers and end users, often lacked insight into how decisions were made, breeding mistrust and skepticism. The rise of regulatory frameworks, specifically the EU AI Act, has spotlighted the need for greater accountability and transparency in AI decision-making processes. The core argument of the article is that AI transparency is crucial for trust and ethical usage. Transparent AI systems allow stakeholders to understand how AI models function, what data they use, and how decisions are made. This understanding helps reduce risks, improve decision-making, and uphold ethical standards, especially in high-stakes environments where the consequences of mistakes can be severe. The data highlights the importance of transparency. 75% of businesses express concern that a lack of transparency could result in increased customer churn. This statistic underscores the critical need for businesses to cultivate transparency to maintain customer trust. Additionally, 65% of customer experience leaders see AI transparency as essential for building relationships and achieving strategic objectives. Regulatory developments such as the EU AI Act reinforce the demand for transparency. This legislation mandates comprehensive documentation for high-risk AI systems, ensuring users receive the necessary information to use these systems effectively. The requirement to disclose when interacting with an AI system showcases a significant shift in addressing transparency in AI governance. The article outlines key components crucial for implementing transparency, such as thorough documentation of AI models, algorithms, and decision processes. Each production model needs exhaustive records, including architecture, training data provenance, and evaluation metrics. Documenting these elements can prevent disputes over AI-generated decisions and facilitate accountability during audits. The integration of explainability into AI design is critical. Explainability should not be an afterthought, but rather a foundational aspect equipped from the model's inception. This approach ensures that the reasons behind AI outputs are made evident, thus improving stakeholders' understanding of potential biases and errors. While the push for transparency is strong, challenges remain. Companies often worry about protecting their intellectual property, as full disclosure of how their AI systems operate may reveal trade secrets. This tension between transparency and proprietary practices complicates compliance and necessitates a balanced approach that enables transparency while safeguarding competitive advantages. Moving forward, enhancing AI transparency can have profound implications for regulatory compliance, public trust, and ultimately the effectiveness of AI systems. Organizations must prioritize establishing their governance frameworks to ensure that transparency requirements are met, and they must continuously revisit their disclosures as AI technologies evolve. In conclusion, as AI continues to integrate into our daily lives, the importance of transparency cannot be overstated. To foster trust, support ethical usage, and comply with evolving regulations, organizations must adopt rigorous transparency practices. The future of AI will demand that transparency isn't merely an aspiration, but rather a standard for accountable and fair AI deployment. In an era defined by rapid evolution in consumer behavior and technological advancement, AI's transformative potential across sectors like retail, travel, and consumer goods is taking center stage. The article by industry experts delves into how AI, when integrated as a comprehensive system, can proactively resolve the persistent challenges faced in these sectors. These insights are critical because they highlight the growing necessity for businesses to leverage their data more effectively in a landscape where merely scraping the surface is no longer sufficient. Historically, enterprises across consumer-focused industries have been overwhelmed by the sheer amount of data generated. Instead of driving insights, however, a staggering 60% to 73% of this data goes unused for analytics, creating significant missed opportunities. Retail environments, travel systems, and consumer goods sectors are no exception. Many businesses have operated on fragmented systems that limit their ability to act on the valuable signals lurking within. This was particularly evident during peak business hours, when crucial insights often went unnoticed. Moreover, failures in product launches paint a troubling picture of misreads within companies. A staggering 85% of new product launches fail within 2 years, with Nielsen attributing many failures to poorly understood consumer needs. This disconnect isn't merely an anomaly. It indicates a broader failure to effectively interpret the wealth of existing data. These challenges reveal a critical need for a solution capable of synthesizing vast amounts of information into actionable insights. The central thesis of this exploration asserts that AI, when executed as a cohesive system rather than ad hoc pilot projects, emerges as a pivotal technology that addresses 3 fundamental issues: trust, time, and cost. This innovation allows companies not only to establish belief in the data, but also to leverage it effectively while reducing the costs associated with its inaction. Those who recognize this paradigm shift are poised to gain a competitive edge over others who continue to rely on fragmented approaches. One of the most striking examples of AI's capability lies in autonomous shelf scanning technology, as demonstrated by Harman's, which successfully reduced out-of-stock items by over 50% and minimized pricing errors by approximately 75%. By employing real-time data collection and analysis, not only did this technology streamline operations, but it also allowed managers to focus on strategic rather than operational tasks, modifying the way retail functions. In the travel sector, AI is significantly shaping future operations. IDC predicts that by 2030, as much as 30% of travel bookings may be generated through AI agents. By connecting disparate systems, from fare engines to predictive maintenance data, AI can create seamless travel experiences that adapt intelligently to shifting demands. This integration not only enhances traveler satisfaction, but also drastically improves operational efficiency. Reflecting on the potential impact of AI in commerce, McKinsey's projections suggest that AI-driven agent-mediated commerce could redirect a monumental $3 trillion to $5 trillion in global retail spending by 2030. This unprecedented redirection indicates a profound shift in how commerce will be conducted, with firms leveraging AI for strategic decision-making being poised to capture a larger share of the market. Looking ahead, the consequences for businesses adopting AI as an integrated solution will be significant. The early adopters who invest in building a robust, data-driven infrastructure will likely separate themselves from competitors who remain mired in outdated frameworks. This transition will foster an environment where data governance is a priority, ensuring that businesses can derive insights that fuel growth and innovation. As the realization of AI's potential continues to unfold, companies must prepare for the shift in how they gather, analyze, and act on data. The signal on aisle 7 has been waiting for decades for someone to act in real time, and the time is now for businesses to embrace comprehensive AI systems that allow them to not just collect data, but to respond meaningfully. The next era of commerce hinges on the ability to metabolize knowledge into action. In an era where artificial intelligence is constantly evolving, NVIDIA has recently unveiled the Cosmos 3 Edge model, a groundbreaking advancement in AI technology. This new model is designed specifically for physical environments, where robots and vision AI agents operate, helping them interpret and interact with their surroundings with remarkable precision. By examining this release, we can appreciate the importance of enhancing real-time reasoning and action generation capabilities in physical AI systems. Before the introduction of Cosmos 3 Edge, AI models were primarily constrained by memory and performance limitations when deployed in physical settings. As machines began operating in more complex environments like factories, warehouses, and hospitals, the need for models to comprehend and adapt to continuous changes became critical. Past models struggled with real-time inference and operational efficiency on edge devices, often conducting computations in data centers instead, which hindered their responsiveness. NVIDIA's Cosmos 3 Edge introduces a 4 billion parameter architecture that allows physical AI systems to achieve data center-level performance in a compact form. This advanced model is specifically tailored for robots and vision AI agents, enabling them to effectively understand their environment, reason using real-time data, and generate appropriate actions based on their assessments. This innovation marks a significant step forward in the quest for intelligent systems that can operate independently in complex physical spaces. One remarkable feature of the Cosmos 3 Edge model is its ability to deliver high-throughput inference while handling memory constraints. Specifically, it can generate 32 actions per inference and operates at an impressive frequency of 15 Hz when deployed on NVIDIA Jetson Thor devices. This level of performance is crucial for real-time decision-making in dynamic environments, thereby enhancing the operational capabilities of robots and AI agents. When compared to other models of similar size, Cosmos 3 Edge ranks number 1 on the Vantage bench for vision analytics. This distinction underscores its superior performance not just in action generation, but also in visual understanding, indicating its high competence in robot policy learning. By setting a new standard for smart infrastructure and robotics, Cosmos 3 Edge offers a promising outlook for practical AI deployment. The architecture of Cosmos 3 Edge consists of two transformer towers that work in synergy. The autoregressive tower is dedicated to processing vision and text tokens, facilitating understanding and reasoning, while the diffusion tower manages vision, audio, and action tokens for prediction and generation. This innovative design enables the model to efficiently share and analyze multimodal inputs, producing well-informed outputs tailored to specific tasks. Cosmos 3 Edge also embraces a unique approach to action representation, accommodating the various ways physical systems define actions. By encoding actions as compact geometric vectors for translation, rotation, and manipulation state, the model can seamlessly connect dynamic visual changes with corresponding physical movements. This capability directly influences the feedback loop between action and visual representation, thereby enriching the learning experience for developers. The implications of deploying the Cosmos 3 Edge model are profound. The ability to fine-tune models for domain-specific applications using post-training strategies can lead to significant improvements in overall accuracy and functionality. As developers continue to adapt these models for particular industries, we can expect to see advancements in interactive world generation and driving scenario simulations, further cementing the role of AI in physical realms. As we look forward, the evolution of the Cosmos 3 series will likely include additional refinements in operational efficiency and speed across a wider range of hardware. With ongoing innovations in interactive simulations and policy training for robotics, Cosmos 3 Edge stands as a critical foundation for the next generation of physical AI applications, shaping the future of robotics and intelligent systems.